Hello ladies and gentlemen, welcome in this MVPDays March edition. This session is about Azure Network Watcher, presented by Peter de Tender, founder of the Azure Apes. In this session you will learn the following topics. First of all, starting with an introduction to Azure Network Watcher and why you should use it. Followed by a detailed walkthrough of the different Azure Network Watcher features, like for example network monitoring capabilities, VPN diagnostics, and overall network routing diagnostics. Starting from a broad walkthrough of the different Azure Network Watcher capabilities, I will zoom in on several of them and showing you what it looks like when using them in a demo. To share a little bit about myself, my name is Peter de Tender, based in Belgium but traveling pretty much 80% of my time around the globe, providing Azure readiness workshops to Microsoft partners, larger Microsoft customers, and Microsoft internal. I'm a Microsoft certified trainer for a bit more than 10 years and an Azure MVP for 4 years. In my free time, I've been busy with writing books, creating courseware, and overall a technical writer. About a year ago, I translated from the former Tag at Yellow Pants team community into an Azure Apes community since the focus on the Azure platform. Now let me start by sharing my personal definition of what I think Azure Network Watcher stands for. Network Watcher is a regional service that enables you to monitor and diagnose conditions at a network scenario level in, to, and from Azure. Network diagnostic and visualization tools available within Network Watcher help you understanding, diagnosing, and gaining insights to your network in Azure. Now the keywords I want to emphasize from my definition is first of all a regional service. This means you have to enable Network Watcher only in the Azure regions where you have network resources running. From a monitoring and diagnostics perspective, it really points to the core capability of Network Watcher, providing you insights on network components and routing. The network diagnostics again, most of the features within Network Watcher are really built to help you with troubleshooting or easily detecting network issues in your Azure topology. And the last one, understanding, diagnose, and gaining insights, you'll really find out through several of the features I'll be covering in the next couple of slides, as well as in the demos, how powerful but yet easy to use Azure Network Watcher is. Although I will show several demos from the portal, note that Azure Network Watcher allows a configuration from the portal, PowerShell, as well as Azure CLI. Several customers that I'm having are already using Network Watcher, where, for example, they're running scheduled PowerShell or CLI scripts to get a time bomb view on their network components, like running a packet capture for between certain virtual machines on an hourly basis. And obviously you could integrate this with Azure Automation, maybe Logic Apps, Azure Functions, to really provide you an end-to-end Azure networking monitoring solution. Now the first thing you have to do is really enabling Azure Network Watcher in the specific regions where you want to run it. So from your Azure portal or even PowerShell that I'll talk about in a minute, you activate Network Watcher and you flag the regions in which you want to use it. Based on your Azure subscriptions, it can be all regions or only a selective of them. Once you enable your Network Watcher features, it will create a default group Network Watcher RG. Now, important to keep in mind is that when you enable this Network Watcher instance using the portal, there's no way you can change the name of this default resource group. Within the Network Watcher resource group, it's creating different instances for each and every Azure region that you selected before, where again, it's following a default name, network watcher underscore the name of the Azure region. And changing this name is not possible from the portal. Now where it becomes a bit more user-friendly is using PowerShell. And I mean user-friendly, giving you some more advanced options. So the first thing you're going to do is updating your Azure Network PowerShell module to the latest version, which is possible through running the command let install module -name Azure RM from Azure Resource Manager .network as the provider and forcing the update. Or another way, install -module -name Azure RM, allow clobber -force to really update all PowerShell related components at once. Once your network provider in PowerShell has been updated, you can move to the other, creating the new Azure resource group for your network watcher object, where this time you actually have the flexibility to choose for a default name. So like in this example here, I'm using new Azure RM resource group -name PS network watcher RG and the given location. Similar to creating the actual regional aspect, it would be new Azure RM network watcher, where you provide a name, somehow pointing to the region to keep it a bit more visible, pointing to the resource group you created before, and again specifying your location. So once everything has been enabled from a network watcher instance on Azure subscription level, the next thing you have to do is deploying virtual machine extensions. So it's like an agent-based approach where you deploy this extension on each and every virtual machine that you want to monitor. I'll show you in a demo how you can enable this from the portal, but now you can also integrate this in, for example, a virtual machine ARM template, making sure that every virtual machine that gets deployed in your subscription automatically has the network watcher extension implemented. Another interesting aspect is the fact that Azure Network Watcher is running on all operating systems. So the full flavors of the typical open source, Ubuntu, Red Hat, SUSE Linux, and obviously also on the Windows platform, where again it all starts from the virtual machine extensions. And moving on, walking you through the different Network Watcher capabilities. So really what you can do with Network Watcher. Starting from a topology diagram, allowing you to build a pretty simplified diagram of what your network related components and resources from a network perspective look like. Variable packet capture is what we used to know as using Wireshark and creating a network capture. IP flow verify helps you in detecting the overall flow between two IP endpoints. Next hop is, as the name says, detailing what the next IP point is in, for example, connecting to a machine on the internet to easily find out what your IP gateway is, for example. Diagnostics logging is one of the core components in Network Watcher, really providing you detailed diagnostics logging. In meantime, there's an integration with OMS dashboards, allowing you to get detailed reporting out of it. Connectivity is a feature currently in preview, where you can again establish connectivity testing on a scheduled basis between two endpoints. Security group view and NSG flow logs are, as you can imagine, are being used for detailing insight on network security groups. What are the different rules in a security group? Which of the rules are being applied on the NIC level, subnet level, and what's the effective outcome for that specific virtual machine? And again, I'll walk you through several of the demos later on. VPN Gateway Troubleshooting is the one component within Network Watcher, allowing you to detect any issues in VPN gateways not communicating with each other. Network subscription limits is not really a technical feature. It gives you a mapping between the default amount of network components in a given subscription and a region, and mapping it with how many of those resources you are already using. And then role-based access control is the last component, where it's really helping you in providing administrative level access to Network Watcher features, but not exposing it to all your administrative accounts. So with that, let's drill down in several of the components that I just described in the overview list, and jumping between some descriptions and some demos. So first of all, topology, the easiest one to use. It's providing you a network level topology overview, showing the various interconnections and associations between network resources in a given Azure resource group. So as you can see from the screenshot, you start from your subscription, select the resource group, the virtual network within, and it's creating a nice looking diagram. Another one, and in my opinion the most used feature so far out of Network Watcher, is packet capture. Again, this one really allows you to capture incoming, outgoing network traffic packets from a virtual machine NIC, where in the past we were using Wireshark, needing to enable some complex network configuration on your NIC, where now you can just run it from within Network Watcher. So two easy features that I want to show you in the portal, how you can enable them and run them. So starting from the highest level, the Network Watcher feature, where again here you can define which of your regions, in which of your regions you want to enable it. And of course, if you don't have any resources or network resources running in a given region, there's no real need in enabling it. Second is on virtual machine level. You install your virtual machine extension, Azure Network Watcher, that you can again select from the default list of extensions, or integrating it directly out of your ARM template deployments. Or afterwards, you could also integrate it just deploying this component, pretty easy. So once all that is up and running, we can start using the Network Watcher features. So the first one, topology. You select your subscription, in there your resource group, and specifying a specific network. And if all goes fine, after a few seconds, it's showing you a nice looking diagram. You can download the topology into a JPEG file, so it's not like a Visio diagram, for example. But imagine in a larger, more complex network environment, based on a rather complex VNet with multiple NICs, multiple VMs, it can be really useful in getting a good view on all the dependencies of the network components. Or the next one, packet capture. So what you can do from here is creating a new capture process. Again, starting from your subscription, selecting the virtual machine, providing a capture name, where you can define if you want to store this in a text file within the virtual machine that's being captured, or in a storage account, where my recommendation would be using a storage account, because it's just easier to retrieve that information later on. You can specify the maximum bytes per packet per session, and the time limit, which I'm going to use for now, up to 60 seconds. Once this packet capture has been created, it will start running. And the outcome of this, after, in our scenario, about 60 seconds, when you're checking your Azure storage account, blob storage, in there it will create a Network Watcher logs container from where you can download the cap file. So it's following a certain folder structure. So imagine that again in a larger environment, you're running this against a couple of hundred virtual machines, executing the capture on like maybe an hourly basis to check your baseline. And we're almost there. So once you download this cap file, you can open it in the Wireshark because it's pretty compatible, or like the tool I'm using, Microsoft Message Analyzer. From here it's pretty similar to the way Wireshark and other network analysis tools are working, providing you a detailed view on each and every step in the IP, TCP and UDP process, where somewhere down here it will show you that I've been using an RDP connection to my server. Again, this was just a basic demo. Obviously it would be more interesting if there's anything wrong on the network level and you really want to troubleshoot and drilling down in the logging of the network capture. But besides that, actually pretty easy and powerful feature to use. So moving on with some other features, IP Flow Verify. IP Flow Verify is described as a 5-tuple packet parameters based verification mechanism, allowing you to detect if a packet is allowed or not. Where again the basic way of working is pretty similar. You start from your virtual machine, you define the source and target, inbound, outbound traffic, and it will tell you if, from a pure IP standpoint, if traffic is allowed or not. And if it's not allowed, then obviously it will also tell you why not. Or the other feature, the next hop, is the component within Network Watcher that you can use to determine the next hop for packets routed in the Azure network topology, mainly helping in troubleshooting user-defined routing. Another feature currently in preview is connectivity. Connectivity check is another verification mechanism detecting the possibility to establish a direct TCP connection from an Azure virtual machine to a specified endpoint. Network Security Group View is the component within Network Watcher showing you the details of the effective and applied security rules to an Azure virtual machine, where it's mapping the default NSG configuration with network interface specific configuration, subnet rules that are being defined, and lastly, most important one, the effective outcome of all the different rules together. Where again the core feature is really helping you pinpointing, providing you detailed views on anything that can help in network traffic troubleshooting. Or the more advanced one, the Network Security Group Flow Logging, is the solution to capture logs related to network traffic, pinpointing if traffic is allowed or denied, using the security rules defined within a network security group. Where again I'm going to jump to 2 demos on Network Security Group details. Where again you start from your subscription, you select a specific resource group and a given virtual machine. It will real-time analyze the network interfaces and from there pointing you to the specific network security group details. Where you can see there's no real effect here. Nothing defined on subnet, nothing defined on network interface, but I still have my default rules available. Now if I would make some changes here, virtual machine 1, and let's say I'm going to add network security group configuration. So this could be Network Watcher VM1 NSG that I'm going to create in my existing Network Watcher resource group, and creating a couple of network rules. So from here the view is pretty similar, and let me add a couple of inbound rules, like the typical ones, maybe allowing RDP, where you can define the basic configuration or the more advanced one. So let me start with the basic. Let's say I want to RDP into my machine. And maybe exposing traffic incoming on port 443. Imagining this would be a web server. Where if I run Network Watcher NSG views again, then this time it will be a little bit different in outcome. A little bit of a delay apparently. Now, interesting from here is the default information, where you can see that although nothing has really been applied, there is still the default configuration valid. Another interesting one is downloading your network security group rules into a CSV file, allowing you to do some nice reporting. NSG flow logs is the more detailed one, giving you detailed log integration. That's the other one. Ooh, small hiccup on the Azure platform. Let's try that again. Let's see if everything is configured fine on NSG level. So all my rules are here. Looks good for now. Worst case, I need to skip this part, but I'm pretty sure you get the core concepts of what it's doing. Wasn't really planned, but not gonna worry too much about it. So moving on with another feature, in my opinion the most interesting and probably most useful one, is VPN Gateway Troubleshooting. By performing a real-time scanning and analysis of VPN traffic between two gateways, it not only determines if the tunnel is up or not anymore, but it will also help you in pinpointing the root cause of why the tunnel is not active. Log file data is being stored in an Azure Blob storage, which can be again easily retrieved and inspected where needed. But besides that, the troubleshooting tool also immediately shows a summary of the analysis in the portal for your information. And obviously another demo on this one, where hopefully this works a little bit better here. So you can start from Network Watcher, selecting your subscription, the resource group, and it will read out your VPN gateways. From here you can store information again in a storage account environment. And running your troubleshooting. So this runs for a couple of minutes. And at the same time, it's providing you some detailed status and creating this log file based on the date and time. And in here it creates a zip file. Where for now nothing is there yet, but it's because the scanning is still running. But in the zip file it contains a couple of text files where you can find the detailed logging information about the VPN scanning. So it's still running for now. I'll keep it running for another few minutes and then showing you the outcome. In the meantime, I can already move over to the last parts of the presentation, showing you another feature, network subscription limits. So what this one is doing is really providing a detailed view on your network resource usage and mapping it with subscription limitations. And role-based access, again, already talked about it in the introduction. So what it allows you to do is defining which admin level access should be granted to your Azure Active Directory groups, allowing you to define detailed admin level access. Like if you're in your on-prem environment, you have a network group, then you can provide them similar lockdown network component access out of Network Watcher without needing to give them admin level access to all other resources. So in the meantime, my VPN troubleshooting is completed. And what it tells you is the VPN gateway configuration is unhealthy, meaning it's not connected anymore. Moving down a little bit, it tells me immediately like your VPN connectivity is impacted because the tunnel is disconnected. And next to that, it's providing me some details. The tunnel could not connect because of IKE or connectivity issues. If you're a bit familiar with VPNs, then you know that IKE is pointing to security configuration. So let's check on the configuration of my VPNs. So VNet 1 to VNet 2. And I can see that my channel is trying to connect, but it's not succeeding. So let me check on my shared key configuration. And it tells me you're using the wrong key, because if I check on my VNet 2 configuration, then you can see that my shared key is different. Where obviously if I go back to the first one, changing my keys, this will allow me to re-establish the tunnel. So the cool thing about the VPN diagnostics feature is that it's not only providing you real-time view if any tunnel is failing, but next to that it's really inspecting the detailed logging and learning from it, reading from it, and helping you in pinpointing the root cause of any problems whatsoever. Now for wrapping up this session, let me quickly show you the network subscription limit. Where it's telling you per region what is the default Azure configuration and what is your current usage. Where obviously this would be interesting to like pinpoint or detect if you're reaching any of the configuration bottlenecks, like the amount of VNets, the amount of application gateways, and so on. So with that, I'm about finished with my session. So to wrap it up, a couple of key session takeaways. Azure Network Watcher gives you detailed insights on your Azure network components like routing, VPN, IP flow, and some other components I covered. Azure Network Watcher can be used from the portal, from PowerShell, and using Azure CLI. And as you could see in the demos, it's really easy to implement, and it's having affordable pricing. So with that, nothing else rests me to say thank you for being in my session. Feel free to reach out on social media or send me an email with feedback or any questions you have on Network Watcher or on Azure in general. Always willing to help you out. Thank you very much and have a nice rest of the MVP Days conference.